So let's talk about hypothesis testing, and you probably remember this from 1401. So when you're doing hypothesis testing, what you're doing is you're going to compare either means or proportions. And this is really where we start getting into a lot of what statistics is, because many of the tests you'll run, you have to make hypotheses, because hypotheses are the way that you have validity and reliability of your study, because you're being very defined about what you're studying. So, hypothesis testing consists of two contradictory hypotheses or statements, where then you make a decision on the data and you make a conclusion. So, for a statistician, what we really do is we set up two hypotheses, we collect our data. For this thing, you're going to be doing sample data. You determine the correct distribution to perform in a hypothesis test, and there's different ones. You're going to look at some means and some proportions, and then eventually we'll go to chi-squared, ANOVA, regression. Those are all hypotheses kinds of tests. And then you're going to analyze your data by doing some kind of calculation where you reject or decline to reject the null hypothesis. And then you make a decision and you write your conclusion. This is really the crux of what you do in statistics. You do this over and over and over. And that's the scientific method. I've just described it in a different way, the way we use it in statistics. So again, you have two hypotheses. You have your null, which we say is the HO, and your alternative, which is HA. In literature, you might see the alternative is H1. They mean the exact same things. They're written different based on the parts of the world or the different disciplines that are using hypotheses. So the equal sign will always be in the null, and the alternative will never have an equal sign in it. And the way I think about this, and if you can see my cursor up here, if I turn this word null on its side, these two L's would make an equal sign. That's how I always remember the null has the equal sign in it. Okay, and there's three types of alternative hypotheses you can have. You can have left-tailed, which is the less than symbol. You can have right-tailed, which is the greater than symbol, or you can have two-tails, which is not equal. Because remember, the equal sign goes in the null. This is the not equal. So let's look at it for one-tailed and two-tailed test for one mean hypothesis test. That means I'm just comparing one sample mean to the population. All right. We refer to left and right tail as a one-tailed. We refer to this one down here, the not equal, as two-tailed. All right, so left-tailed, my null will be the mean is greater than or equal to the population mean. The alternative is that the mean is less than the population mean. For right-tailed, it's the opposite. The null is the mean is less than or equal to the population mean, and the alternative is the mean is greater than the population mean. Now, two-tailed is kind of different because the null for the two-tailed is the mean equals the population mean. The alternative is it doesn't equal the population mean. This equal sign, this not equal sign means it can be less than or greater. That's where we have two-tailed. I'm not caring if it's less than or greater. I just care there's a difference, and that's where that two-tailed comes from. So examples of left-tailed test, you're going to see wording like less than, below, under. The null for this one, this greater than or equal to, can be written as at least. So make sure you know these kind of word choices. Examples of right-tailed, the null is going to be no more than. So like I say, I'm going to give you no more than $100. That means I can give you $100 and less. The alternative for this one down here is greater than, above, or more than. So for the two-tailed, the null is going to be equal. It could be is, could be no difference, where the alternative is not equal or there's a difference. So let's do some examples. The mean number of years Americans work before retiring is 34. So I'm saying is, which means it's equal. So then I'm going to write my null as the mean equals 34. And again, remember, the equal sign is in the null hypothesis. Because this equal sign is here, that means my alternative is not equal. So the alternative hypothesis is the mean is not equal to 34. So The mean number of cars a person owns in their life is no more than 10. So that means most people have 10 and below cars that they own in their lifetime. So again, because I'm saying no more than 10, I'm doing that equal to 10 and everything below it. So the way I write that is the null is the mean is less than or equal to 10. And that equal sign right there is okay because again, this is the null hypothesis. The alternative is the mean is greater than 10. So another example, Europeans have a mean paid vacation each year of 6 weeks. Okay? I didn't say it was below 6 weeks or above 6 weeks. I just said it was 6 weeks. So that means my null hypothesis is my mean equals 6, and the alternative is the mean does not equal 6. So another example is private universities' mean tuition cost is more than $20,000 per year. The null and the alternative hypothesis are, okay, I'm going to start with the more than $20,000 per year. I'm going to do my alternative first. So the alternative is the mean is greater than $20,000 per year. So then that would mean that the null is the mean is less than or equal to $20,000 per year. So think about it this way. I could either start with my null hypothesis or my alternative. It's really based on what the question is asking. So let's do this one together. A business owner believes that the mean number of days per year that his sales staff travels is less than 53. All right, that less than, it doesn't have anything of an equal sign in it. It doesn't do anything, but just have that less than symbol. Remember, less thans are in my alternative hypothesis. So I'm going to do my alternative hypothesis is the mean is less than 53. The null hypothesis would be the mean is greater than or equal to 53. So that's my answer. Again, here's my less than 53, and I do the mathematical opposite to do the null. Let's do a number one. A business owner believes that the mean number of years he retains customers is 5. State the hypothesis. Okay, again, it's that is, so that's the equal sign. And I know the equal sign goes in the null, so the mean equals 5 years. My alternative is the mean does not equal 5 years. He doesn't really care if it's less than 5 years or greater than 5 years. He just believes it's 5 years, and that's what I have to test on. So another thing that we can do is one-tailed and two-tailed test for one proportion hypotheses test. Okay, proportions are really percentages, fractions, decimals. And again, you're going to see the same thing. Left-tailed, the proportion for the null, the proportion is greater than or equal to the number. The alternative is the proportion is less than the number. Right-tailed, the null is the proportion is less than or equal to the number. The alternative, the proportion is greater than that number. And again, for the two-tailed, I need to clean up the slide. The proportion equals that number or the proportion does not equal the number. All right, let's get that. Rid of that. Boom, two-tailed. Okay, that looks better. All right, let's do some examples. At most, 60% of American voters vote in the presidential election. All right, I've converted this percentage to a decimal, and that's what you're seeing right there. So it says at most. So that means, remember, if I give you at most $100, that means I can give you $100 and below. So at most 60%. So the null is the proportion is less than or equal to 0.60. And the alternative is the proportion is greater than 0.60. Doing it just like the means, we're just dealing with proportions now. 29% of senior citizens drink alcohol during the weekend. So I didn't say that less than or greater than 29%. I just said this is a fact. So the null is the proportion equals 0.29. The alternative is the proportion does not equal 0.29. All right, let's do another one. About half of Americans prefer to live away from the cities given the choice. Okay, half. 1/2, 50%, 0.50. So I didn't say anything about less than or greater than. I just said about half. So the null is the proportion equals 0.50, and the alternative is the proportion does not equal 0.50. All right, The chance of developing breast cancer is under 11% for women. Here's the null and the alternative. All right. Under 11% is the same thing as saying less than 11%. So if I go with my alternative first, P is less than 0.11. So that would make my null P is greater than or equal to 0.11. So what are we doing? One mean hypothesis do this. They compare a sample mean and a sample size to a population mean and population standard deviation. And you may not always have the population standard deviation. Let me go back to that, but we're going to go into the depth of that in just a few minutes. Okay, so one proportion hypothesis, you're looking at a sample proportion, a sample size, and you're comparing it to the population proportion. You may not always have your sample size, but you will know basically what you're doing is you're comparing those samples to those population proportions.